All right, so today we are diving into a really deep physics puzzle. There's this famous argument, a real showstopper, that seems to forbid a whole class of theories. But then there's a new framework that claims it's found a loophole. We're going to explore how you might, in theory, send a message faster than light, and why a completely different view of reality itself might mean you can't and never will.
So here's our roadmap for today. We'll kick things off with this idea of a quantum speed limit. Then we'll dig into the superluminal signaling argument itself, how it's supposed to work. After that, and this is where it gets really interesting, we're going to uncover the 3 hidden assumptions it's built on. Then we'll introduce this pretty wild idea of a static 4D reality and see how that new picture makes the entire paradox just melt away. Finally, we'll talk about the choice this all leaves us with, a fundamental choice about what reality really is.
Okay, so let's set the stage. Our story really starts with a big conflict in physics. For a long time, people have been kicking around this idea of let's call it a deeper version of quantum mechanics, a non-linear version. Basically, one where the rules of the game can change depending on the state of the system itself. It's a really compelling idea, but there's a huge problem. A massive roadblock in the form of a theorem that basically says, nope, can't do that.
And this brings us to the core question, the one that really drives the whole conflict. Could you actually use that spooky action at a distance from quantum entanglement to, say, send a faster-than-light text message? Well, according to something called the Gisin-Polchinski theorem, we'll just call it the GP argument, if quantum mechanics were nonlinear, the answer would be a mind-blowing yes. And that's a universe-breaking problem. It would completely violate one of the most fundamental rules we have, Einstein's cosmic speed limit.
So how does this argument actually work? I mean, how could adding this one little tweak, non-linearity, suddenly unlock faster-than-light communication? It sounds pretty out there, right? Let's walk through the logic, step by step. You have to admit, it's a really clever piece of reasoning.
Okay, so check this out. This is the argument, and on the surface it looks totally airtight. Imagine you've got Alice and Bob, and they share some entangled particles. From Bob's perspective, his particle is in a state of total uncertainty, a maximally mixed state. Now Alice, who could be light years away, makes a measurement. Here's the key step. The argument says her choice of what to measure instantly forces Bob's particle into one of 2 different statistical piles. And here's the punchline. Because we're assuming the rules are nonlinear, those 2 different piles would actually evolve in measurably different ways. So all Bob has to do is watch his particle, see how it's behaving, and boom, he instantly knows what Alice did. Faster than light signaling. That's the paradox.
Right, so that argument we just walked through, it seems pretty solid. But, like any really good magic trick, it only works if you're not paying close attention to the setup. The source material we're looking at today argues that this seemingly perfect logic is built on 3 deep and usually unstated assumptions about the very nature of reality itself.
And here they are. This is the foundation. Let's be really clear. The entire paradox only holds if you accept these 3 ideas as true. First, that time is a real, flowing thing. Second, that Alice's action actually causes a physical change over at Bob's lab. And third, that her mathematical description of Bob's particle tells the complete story of its physical reality. So, what if one, or maybe even all of these are wrong?
Let's break these down. The first one is ontic time. This is basically your gut feeling about how time works. The idea that there's a real universal clock ticking away, a now that sweeps across the cosmos. It means the statement Alice measures before Bob detects is a real, physically meaningful fact about the universe. It seems totally obvious, but in modern physics, that's a profound assumption.
The second assumption is causal collapse. This is all about that spooky action at a distance. It's the belief that when Alice measures her particle, a physical event, a collapse, is triggered, and its effect instantly travels across space to physically alter Bob's particle. It's taking this spooky action and treating it as a literal cause and effect mechanism. And the third one, this is a bit more subtle, but it's absolutely crucial: density matrix completeness. This is the assumption that the math we use tells the whole story. The GP argument hinges on this idea that the way Bob's particle got into its state is different depending on Alice's choice. The argument assumes this difference in mathematical description must correspond to a real, physical difference that Bob can actually detect. It's saying the description is the reality.
Okay, so let's move on to the alternative. This is a framework proposed in the source material called Timeless Counterspace Shadow Gravity, or TCGS for short. And what's so interesting about it is that it doesn't try to solve the paradox head-on. Instead, it challenges those very assumptions we just discussed and proposes a completely different picture of reality.
So what does this TCGS picture look like? Well, it starts with a few core ideas that change everything. First, whole content. I want you to forget time as a flowing river. Instead, imagine reality is a static, four-dimensional block that contains every single moment, past, present, and future, all at once, like a finished sculpture. Second, identity of source. Those two entangled particles, they aren't two separate things. They're just two different viewpoints of a single geometric feature on that 4D sculpture. And finally, shadow realization. This says the 3D world we experience every day is just a shadow cast by this deeper 4D reality. We're living in the projection, not the real thing.
And this is a brilliant way to think about it. You might have heard of the ER equals EPR idea, which suggests that entangled particles are secretly connected by a tiny wormhole. In that view, the correlation isn't some spooky action, it's a hidden geometric connection. Well, TCGS proposes something structurally similar. The correlation comes from the identity of source. It's one object viewed twice. And the reason you can't send a signal isn't because of a non-traversable wormhole, but because of a projection constraint that's just built into the geometry.
So, if we adopt this TCGS viewpoint, with its timeless 4D reality, what happens to that Gisin-Polchinski argument? Well, the paradox doesn't get solved, it simply dissolves. The problem, it turns out, was never really there to begin with.
And this is the absolute key. In the standard view, the one that underpins the GP argument, Alice's measurement is an action that causes a physical change in Bob's state. But in the TCGS view, her measurement does nothing of the sort. It simply selects a perspective, a way of slicing, or viewing the static, unchanging 4D object. The object itself is completely unaffected by her choice. And what's fascinating is that Nicholas Gisin himself, one of the original authors of the argument, pointed directly to this critical assumption way back in 1990. He called the instantaneous preparation at a distance the most delicate point. He knew this was the linchpin. The TCGS response is simple and direct. That delicate point is a fiction. Alice doesn't prepare Bob's state at all. She just looks at their shared reality from a particular angle. Because the underlying 4D object is static, and her choice is just a choice of perspective, Bob's reality remains entirely unchanged by what she does. Therefore, the core mechanism of the GP argument, the idea that Bob can distinguish between two different physical states prepared by Alice, is based on a category error. According to TCGS, they were never different physical states to begin with. They were just different mathematical descriptions of the exact same underlying geometric object. So there's nothing for Bob to detect, because there's no difference to detect.
So what does this leave us? The conflict isn't just about equations or whether quantum mechanics can be nonlinear. It goes much deeper. It's about ontology, our fundamental theory of what is real.
You see, the TCGS framework doesn't disagree with the mathematical steps of the GP argument. It agrees that if you assume reality works that way, the conclusion follows. What it disagrees with is the entire picture of the universe that the math is assumed to describe. It argues that a nonlinear physics is compatible with no signaling, provided you adopt this different, timeless ontology.
Ultimately, this leaves us with a profound question about the world we live in. Is our deep, intuitive experience of time as a flowing river a fundamental feature of the cosmos? Or is it merely an artifact of how we, as 3D beings, perceive a static, timeless, and vastly more complex 4D reality, a finished map that we only get to see one location at a time? The answer to that question determines which laws of physics are even possible.